crypto hubs. And now, without further ado, let's kickstart today's deep dive. Today, we're going to tackle one of the most urgent problems in rapidly growing AI, and specifically in the agent economy. How do you actually secure an autonomous agent that holds keys and signs transactions? Today, AI agents are moving incredibly fast. They are managing wallets, calling APIs, and executing on-chain actions, often without meaningful guardrails. The infrastructure to keep them safe is still being built today, and today we're uh, and today's guest is one of the people that actually building this. We're incredibly lucky to be joined by Kevin Jones. Kevin is the DevRel engineer at Agent Node, the team behind the graph, and the founder of OneClaw. OneClaw is a security layer purpose built for AI agents with a background, and Kevin, with his background in enterprise security at F5 networks and a deep roots in Web3, he sits exactly in the intersection of AI automation and on-chain security. He's going to walk us through today what it actually means to build your AI agent with a leash, a wallet, and a safety belt before the execution. So let's bring our speaker up to the stage. Wait a second. Awesome. Hey, Kevin. It's great to see you, man. You're still on mute, so just a sec.
Sorry about that. Thank you so much. It's so great to see you. Yeah, thanks so much for having me. That was a great intro, by the way. Great job.
I hope I didn't mess up your intro, but I would love if you can do a short intro about yourself as well. So I didn't completely replace you in that.
No, yeah, you did great. That was amazing. Yeah, so I can just do a brief intro too, just to kind of help people out. Yeah, I've been working in the Ethereum space for the past 7 years, primarily like supporting the Build Guild and going to a lot of ETH Global hackathons and helping the community a lot. And I've been working in the graph ecosystem as well for the last 3 years. Very exciting stuff. And yeah, I'm an educator, content creator. Really really excited about the future, especially now with AI. And so I've pivoted recently to try to focus more on AI. And yeah, I'm really excited to what I'm going to show you guys today. So it's really cool.
Awesome. I'll try to be a smart student. No promises, but I'll do best.
You'll be amazing. Yeah, that was great.
Awesome.
Cool.
So feel free to share your screen.
Okay.
I'll add to the stage.
Let's do that. All right, I will share my screen here. So let's do that. Share screen. We'll do entire screen. Boom. And then let me know if you can see okay. Are you able to see that?
Yeah. See that. And
awesome.
For
Cool.
the audience joining us today, feel free to comment any questions that you have that you would like me to stop and try to ask Kevin during the event. This is supposed to be like a two-sided communication, so feel free to just like write whatever you would like us to touch or stop to explain more. And yeah, Kevin, the stage is yours, man.
Awesome. Yeah, please feel free to ask questions. I want you guys to get the most out of this that you possibly can. We're going to talk a little bit about agentic security today. We're going to talk a little bit about cool open source tooling and kind of how you can build an agent quickly. I wanted to keep this kind of very, very, very easy for people to follow. And one of the nice things about some of the stuff that I've been working on is I've made everything as I'm building very automatable. In the future, like I'm very, very confident that AI agents are going to be doing a lot of the normal stuff that a human needs to do. And in order to do that, you need to be able to orchestrate tooling really, really easily in like single commands or like by passing like URL arguments. And so we're going to be talking about Scaffold Agent today. Excuse me. Scaffold Agent is a starter kit that essentially lets you go from zero to AI agent super quickly, and it's going to allow you to bootstrap an application that is, AI agent secure with kind of like some guardrails in place, and we're going to kind of talk about that as well with a nice little chat UI, and very, very useful. So, but before we get into that and like what Scaffold Agent is and why it's important, I want to just kind of talk a little bit about some of the problems that we want to try to address with what we're doing. We have a few issues with, I would say, the current kind of AI agent kind of narrative with just agents in general. One is that people are using maybe like a desktop application like Claude Desktop or ChatGPT or maybe Cursor or some of these other like agentic kind of IDEs. And people are either pasting in like private keys or API keys or secrets into the chat, or the agent itself is like sucking up those env files, right? So you have an env file sitting somewhere and it just reads it in and doesn't even tell you, and then it go ahead and tests it for you, and it just kind of, that's a huge issue in itself, because those keys leave your machine, right? They go out and they end up somewhere else. So we want to try to avoid that as much as possible, but it's very difficult. Like, how do you give your agent secrets, right? So we're going to talk about that today. We're also having issues with prompt injection. So, there's supply chain attacks that are happening, right? Where like packages that are inside of existing projects have some known vulnerabilities or unknown vulnerabilities. Or it could be even that your agent itself on your desktop is going out and reaching an endpoint that might be doing a web search tool that has some malicious content as well, right? And then there's some like potential for code execution or something to happen on your machine, right? And then the last thing is like people are just taking private keys. Like, let's say you want to give your agent a wallet, how do you do that, right? Like, how do you give your AI agent a wallet to make transactions, or to pay over X402, or to do some of these things? And this is people just loading, again, an env file on their local machine, and the agent is sucking that up, using it, but it's got the entire string. And so this is a huge issue. We don't want that. And then the last thing is there's no really way to audit. Like, most of the AI agent tooling is not very audit friendly, because they don't really want to give you all of the logs and the context of what happened, because it's kind of like they're like that's how they're making money, right? They're like taking in all of this context that you're sending, but they don't really provide you a good audit log and way to like revoke access, right, to your agent. Your agent kind of just has like somewhat unprotected privileges, right? And so what it's ending up with is all these different attacks that we're seeing, right? Gemini API key leaked for $82,000, in 2 hours or two days. Banker had an issue where someone took the Banker API key and then they did a Morse code attack. They like used Morse code to use that and gain access to that private key, and then was able to drain $180,000 in tokens. The Sigma attack, which was over $200,000 in Ethereum, where there's just a private key like sitting around somewhere. And then the very last thing is like the cloud cost bills, right? An agent was just kind of in a loop and racked up a $47,000 bill. So it's obviously an issue, right? We have this issue. We're going to talk about how we can try to solve some of these problems today. First of all, I want to also set on like why we shouldn't have the private key on the disk. Well, first of all, like again, that config file or that env file could be easily sucked up by an LLM and then sent off without you even knowing it, unless you have proper guardrails in place, which most people don't know that you need to like create a Claude ignore and a cursor ignore and these like special files to prevent AI from reading those things. And then even that, sometimes AI goes around you and figures out a way to read those files. It's actually quite interesting. And so also, if you have a private key in your memory, it can be dumped, right? And it can be stolen from the memory dump. So that's another thing, is you don't want to just keep your key just sitting around a memory. You want to make sure it's just like used and then thrown away. And then the same thing goes for the LLM. There's always a chance that your LLM is going to get that key and then send it off somewhere else, maybe with a prompt injection. So a prompt injection is when you were typing in a prompt to the chat, but maybe something is intercepting that prompt and changing it. And so what we're seeing is that people are infiltrating supply chain attacks on packages and then stealing information through that to that prompt through a prompt injection. We also don't have any way to, like, if we just give the raw private key, we have no way to like impose some kind of rules around like that private key, right? So what you really want to do is role-based access control. And this is where we do something where we give an agent access to use a key, but the keys really never have to leave secure hardware. And then we're going to talk about that today. And this is an option for you, obviously. It's not the only way to do it, but there's lots of different ways. But we're going to talk about our Intents API with OneClaw and kind of some of the stuff it gives you. And we can do these, again, these like guardrails in place. And we can basically make executed transactions on 109 chains across EVM. So very, very cool. Okay, cool. Let's kind of go into the meat and potatoes. So we're going to talk about Scaffold Agent. Scaffold Agent is basically a starter kit. So if anyone's ever heard of Scaffold ETH, it's very similar to Scaffold ETH. Scaffold ETH is created by Austin Griffith and the Biddle-Giddle. And as you guys know, I've been involved in the Biddle-Giddle for a very long time, for the last almost 7 years. It's been a while. And the cool thing about Scaffold ETH is that it was always like a good starting point. Like you could just run one command and it would bootstrap an entire application. So I wanted to build a very similar experience for Scaffold Agent, which was specifically for AI. And so I kind of used a lot of the existing packages. And the idea is that it's a project that is wired up with everything you need out of the box. And it's got it's a monorepo, so it's got a chain, and it's also got a front end, and it's got a just file. Just is similar to make, if anyone's ever used make before. It's got these very, very nice, easy commands that you can just type, like just deploy or just start or just chain will spin up a chain. So it's very easy commands that you can just type to like orchestrate, right? We also, out of the box, it comes with a lightweight kind of like blockchain tool on your machine. So you can use Foundry or Hardhat, and you can then deploy a smart contract for your AI agent. So your agent can have its own kind of chain, its own kind of state and stuff like that, and we'll show it off. And then we generate deployer keys, and we generate an agent key. So what that means is that you have a special account, a special wallet address for the deployer, and we have a special wallet address for the agent, because agents need wallets, right? Now agents need a way to pay for things and stuff like that. And then you can store your secrets either in an encrypted env file, or you can use OneClaw, which we'll talk about what OneClaw gives you and give you an option there. And then we use Vercel AI SDK, which gives you this kind of like streaming chat with your AI agent. And we also use agent identity platforms, ERC 8004, so you can register your agent in like a way where it can be discovered by other AI agents. Like let's say you're building an AI agent that you want to make money with, right? You want to maybe make money with X402. You might have like a service that you expose, right? And so you would want to register that agent so that it can be found, right, by other AI agents. And that's what ERC 8004 does, is it gives you a way to register. And then we're going to use Shroud, but we're going to show why you could use Shroud. But Shroud is essentially OneClaw's LLM security tool. So it's kind of like a proxy. Most people are using like Anthropic Claude, like either like Opus or Sonnet, or they might be using OpenAI, right? Or they might be using Gemini, Google Gemini. What we're going to use is Shroud, which is a reverse proxy that protects your LLM traffic to make sure that the secret's not going to make its way to the provider, which it would be like Google or Anthropic or of them. And we're going to route all of our traffic through there, which is going to give us that security stuff that we talked about. And then the other thing is we create, just like Scaffold ETH, smart contracts have this thing called an ABI, right? It's basically kind of like a map, right? So if anyone here is familiar with ABIs or not familiar with ABIs, you essentially have like, in a smart contract, you have functions and you have variables and things like that. And it's, in order for your front end to understand how to work with them, you need what's called an ABI. It's called an application binary interface. And what we do is we generate a bunch of types for that ABI to make your agent be able to immediately know how to work with the smart contract. So this is kind of nice. Like your agent can have its own like smart contract that it manages and you deploy, and your agent knows exactly how to talk to it, or other agents might know how to talk to it as well by using this kind of type safe ABI. So it's kind of, again, it's a boilerplate starter kit kind of experience. And the idea is that you don't have to do this by hand. We're just going to run one command, and we're going to just use this kind of like experience, kind of as you go experience on how to set this up. And we'll show it off in a little bit. But I do have slides to kind of prep up to that so that people can really understand what's going on. So the single command that you run is this. So it's an npx command, and it's a special package called Scaffold Agent, right? So we publish this package. It's open source. Anybody can go to the GitHub on the OneClaw AI GitHub and see the source code for it. We'll show it in a little bit here. But basically, again, it's just it's kind of like a wizard, a boilerplate kind of wizard. And it's going to ask you 7 questions that are going to identify what kind of an agent you want to build, right? How do you want to store your secrets? Do you want to use an agent identity? Do you want to use ampersand, which is a tool for X-Row2 payments? What LLM provider do you want to use, like Gemini, OpenAI, Anthropic? Do you want to use a chain framework? Like, do you want your agent to have like the ability to write its own smart contracts and deploy those? And if so, what do you want to use, Foundry or Hardhat? And then the very last thing is like, what app framework, like Foundry, Next.js, Vite, or Python. So each one has its own benefits. I personally really like Next.js, so we'll probably show that off. And then what you get at the end is this mono repo. It's like just a folder, and it's got everything set up for you, and you'll be able to start chatting with your agent essentially right away. If you use OneClaw, we'll store all the secrets for you in a secure way, and we'll also enable the intents, which we'll talk about in a little bit. Any questions so far on the chat at all, Amit?
I just wanted to clarify maybe, is this useful also for general use if you don't yet connect your wallet? Like, I think there are like more perks to that than just doing on-chain work.
Yeah, for sure. Yeah, if you're not going to use a wallet, it's still really good to use this, right? Because if you're building an AI agent, there's a good chance that your agent's going to have a lot of secrets that it needs. So it could be like an API key for some kind of tool that you're integrating with. It could be an API key for the LLM. It could be some kind of random, password that you set for some integration. So yes, even just for not like wallets, yes, this is really valuable, because what we're going to do is, instead of giving the agent all of the secrets, right, and loading them in on a server somewhere, we're just going to give the agent one key, one API key, and then that agent can be, that access to all those secrets can be revoked, which is really, really powerful, because if your agent gets hacked, you probably want to just like cut it off, right? And so this is a way for you to like, or rotate the key as well. And so yeah, it's good for secrets or wallets. Both.
Awesome. Thank you. You can continue.
Okay, cool. So the options for storing your secrets are obviously up to you guys. If you're doing things for testing, like a plain env file is usually fine, right? But the minute you actually load a real account, so let's say you go to Stripe, and you go to Stripe and you're going to give your AI agent the ability to take in payments on Stripe, or maybe make payments on Stripe. Well, that's like you're starting to deal with a real bank account, you're starting to deal with a real production key, and a plain env is not the best way. So the next best bet is you can encrypt the file locally, which you can use, the env.secrets.encrypted type format, and you can encrypt it with a password. But that doesn't scale for if you want to ship your application to a production server, because that means someone at some point is always going to have to start up your server by typing in the key, right? So what we want to do is use OneClaw, which, you don't need to do this, but this is just kind of a recommended way. And what OneClaw does is it stores the secrets inside of a hardware security module. So this is like what banks and military and like large corporations use for storing their secrets. If they don't want to store them on a thumb drive or somewhere in like the actual data center, they usually store them in an HSM. And then they do some kind of, depending on what the comfort level is for like how those secrets are stored, you can custody part of the key with like cryptography using what's called multi-party computation. And we'll get to that in a little bit. But basically the idea is that you can cut the key up. So if you're worried, like some people are worried, like, oh, well, it's on the cloud, like someone could get it. But you can also like break the key up. So you can hold half of the key and then store half in the HSM. You can also do like multi-party computation against different clouds. So there's lots of different ways that you can make it even more secure. But this is actual physical hardware where it's tamper-proof. Like you can't like walk up to it and just like plug in a USB stick and like dump everything out. It's not like that. It's the only way to communicate with it. Even like OneClaw as a company, we can't see the secrets because they're wrapped with envelope encryption that's tied to your user account with OneClaw. So it's super secure and very, very protected. So we're going to probably use that for the demo, but you do have options. You can do whatever you want. You can either spin up a single agent, which is what we'll do today. We won't get into the swarms, but we also support swarms, which is really cool. Like, let's say you want to have 60 or 50 agents that you're running all at the same time. Scaffold Agent supports that. It has this -- swarm option, and it will spin up wallets for all of your agents, and they'll all have it. So let's maybe say you want to do like a DeFi agent, and you want them to do some buys on like maybe on a Uniswap or something like that, some swaps. You can have them kind of repetitively do stuff in this swarm mode. So it's really, really cool. It's lightly tested, so if you have issues, let me know. But it's open source, and we'll show the repo. But we're going to do just a single agent today. The LLM provider. Okay, so again, I don't know what everyone's using these days. Everyone has their own kind of like preference. Some people are using Claude, like Opus. Some people are using OpenAI, ChatGPT. Some people are using Gemini. It's really just a preference. But what we're going to use is probably OneClaw's LLM, because we also support, we are an LLM provider as well. So you can do all of your LLM billing through OneClaw. And what's nice about that is you don't have to have a second account. So you don't need to have a Gemini. So if anyone's familiar with Open Router, we are kind of like Open Router. You can do all of your LLM through OneClaw, and you can choose whatever model you want on the back end. So we're kind of like a reverse proxy. You do all of your LLM through there, and you can pick whatever model you want, like you do with Open Router. And so that's going to be the easiest one. So we're going to do that. But we support all of it. So you can either store your key inside the vault for OneClaw and use that key will be used and read during each request, or you can pass the header. And I'll show what that looks like. So you have basically you have lots of flexible options on how you want to use LLM, or you just don't use it for LLM at all. Maybe you just want to store your LLM key locally on the in the agent. You can do that as well. So lots of options. For the chain, we're going to choose a chain. So if anyone is not familiar with this, it's like a virtual blockchain that we're going to run locally to be able to test. So Foundry is a Rust kind of tool chain. It's really fast. It's kind of newer. Hardhat is all TypeScript heavy, kind of TypeScript focused, and it's also really good. Or you can just skip the chain completely and just, it won't have any, the agent won't have its own smart contract. But we'll probably show it off just so you guys can see what it looks like. For the framework, again, it really is up to you. I like Next.js. It's really easy to use. It's got a lot of really cool features. It's got this kind of like debug page, which is really, really cool. It does all, it's very, very type safe kind of experience. But we also support using Vite or Python A2A. If you're building a Google A2A agent, then this is really useful, because then your agents can talk to each other with what's called the agent-to-agent protocol. Each agent will have its own dedicated A2A endpoint. If you're just using like creating a web app with one agent, then probably either one of these is fine. I would default to Next.js. It's going to be the fastest, and it's going to have the most. It's going to be the most developed and look the best.
Just a
Yep.
short question, but on Next.js, do you also have a way to make agents communicate? Maybe less efficiently than A2A, but is it also possible?
Yeah, that's a good question. Yeah, it's possible. It's possible, but out of the box, I guess no. So by default, the Python framework, I think it will create what's called an agent card. So with Google A2A, the way it works is it's kind of like got a very special endpoint that's listening on a certain port. So what we do with this is if you spin up like 4 agents, each agent's going to get their own unique port. And so this is kind of default. In this scenario, Next.js only listens on one port. And so you would need to do like routing. So you would have to build it yourself, but it would be possible. Yes.
Awesome. Thank you.
Those are good questions. I love these questions.
Yeah, we have some waiting from the audience, but I'll wait until you finish this, the next.
Okay. Perfect. Yeah. So what do you get out of the box, right? After you've gone through and you've run this command, you get this. You get a root project. You get the just file, which is really useful with all the commands. You get a scripts folder with like some easy scripts to do things that are kind of useful. But then you get a packages folder with 2 packages, Foundry and Next.js, right? And Foundry is the chain. Next.js is the front end. You get the shad CDN, you get all the stuff, you get an env file. Sorry, my son just walked in the room. Okay, buddy, daddy's on a meeting, okay? Okay, he's gonna join for a sec. Okay, so the just file is super cool. So the just file, again, is just all these easy commands. So we wanted to make it as easy as possible for a developer to be able to like orchestrate the environment. So if you want to start the blockchain, you just run just chain. If you want to deploy the smart contract, you just run just deploy. If you want to start your front end, you do just start. If you want to fund the deployer and the agent account, you do just fund, right? So these are really easy to remember. Like as you start, this is a really good also like hackathon starter kit, because you can just, oh, I know exactly how to work it. It's going to do all the things for me, and I remember these commands. So the just file is really, really useful. Okay, so to get up and running, again, we can just run the chain, fund the account, deploy the smart contract, and start the front end. And that's really it. So we'll bootstrap it here in a second, but these are the only 4 commands you need to run, and you'll be up and running. You'll need to use multiple terminals, because you're going to want to have one with the blockchain always running here, and you're going to want to have one here that's where your front end is always running. Then you'll probably have a third one that you might type other commands with. So you'll need to have a few terminals open, just so you know. That's just kind of a caveat on how you orchestrate. So what lands in the vault? So we talked about earlier, like if you want to use an env file locally, then it's going to store the private key in the env file, right? But if you're using OneClaw, the idea is that we want to lock away the private key so that it really never leaves hardware, right? It gets locked away. And so what we do is we store away the two private keys. One is, they're both EOA private keys, which are externally owned accounts. And one is for deploying the smart contract, and one is for the agent, dedicated agent private key. And so these are locked away in the HSM, and they're never accessible, because what we do is we enable what's called intents. And the intents API is like a way for us to do signing inside of the trusted execution environment. So I didn't talk about that earlier, but the idea is that we have physical hardware inside of, so OneClaw is deployed in Google Cloud, and we use HSMs, which are physical hardware managed by Google, and we use trusted execution environments, which are also physical hardware managed by Google. And these are, again, they're cryptographically impossible to access without the authentication that the user has. So in other words, even me as an administrator, I could never log in and see the traffic going on inside of these containers because these are running on physical AMD SEV hardware, right? It's a special kind of hardware that's its sole purpose is for cryptographically locking away what's happening inside. And so we store these keys, and once we give the agent access to sign inside the TEE, the agent will never have to see the key, right? He'll just prove that it can use the key, and it will send in an authentication to sign stuff inside the TEE. And if you don't understand that, we'll try to cover it again. But basically, again, this is the idea is that the agent doesn't even need to have the key. It would just sign inside the TEE, and it can either execute the transaction in the TEE, or it can send back the signature payload, and then the agent can then do its thing different ways. And then we do need one ENV file, and this is for the agent's API key, right? So the agent's going to have its own unique API key that is scoped for that agent. And so the idea is that, sorry about my son here. Okay, so.
I feel good not to be the youngest student here.
There we go, yeah. Okay, so again, the idea is that the keys are not stored on the agent at all. They're only decrypted in memory on the actual HSM or in the TEE. We have these kind of like path-based scoped policies. We have an audit log, and we can rotate the keys if we need to, if ever needed. And when I mean rotate the key, I mean rotate the agent key, right? We don't need to touch these keys because these keys get locked away in the hardware security module, and they never leave the TEE. So they're secure. They're like super secure. And so what we can do is this. We can create a signature request, right? To create a signature using the Intents API, and we can basically, sorry, this is not a signature request. This is a policy that says, well, we're only going to allow this AI agent to send a transaction on base, and we're only going to allow them to send to these addresses, and we're only going to allow them to send 0.1 ETH in a transaction, and we're only going to allow them to send 1 ETH max per day, right? And so this is kind of like a policy. And then when the agent wants to submit to the actual transaction, it just does this kind of submit transaction, sends in all the details that it wants to do with the call data, and then this will enforce all of the guardrails. And then what we do is we sign the transaction in Tenderly. We simulate the transaction in with Tenderly. Tenderly is kind of like a chain kind of simulation tool. And we sign the we sign it inside of the HSM, the TEE, and then we broadcast and create the audit log. You're getting a free song too as part of this workshop. Okay, Sebastian, you want to go find your brother? Go find your brother. Okay. So, yeah, is there a question at all?
Just if it's a good time to stop for some questions from the audience.
Yeah, let's do it. Yeah. Mm-hmm.
So first one, Gan wanted to know what's your take on TEEs. Now, we've had some controversial opinions on TEEs before, and would love to hear yours as well.
Yeah. I mean, I think that there are some TEEs that are, Sebastian, stop. There are some TEEs that are not true, like I guess AWS TEEs are not certified as actual like cryptographically proved TEEs. The AMD SEVs, I think that they are. I'm in a consortium group that we meet every like Thursday, and every other Thursday. And the general consensus is that not all TEEs are actually like fully secure, but there are certain models that are better. So I'm in the kind of the path that the AMD stuff, and if it's a reputable cloud provider, they're using best practices and best security kind of guidelines, and I think they're fine. And I haven't seen any like major like issues as far as like hacks or like cloud providers having problems that sensitive stuff is getting leaked or something like that. So I think they're fully safe, in my opinion. Even the AWS ones, as even there's this kind of like debate about how safe those ones are compared to the AMDs, but I think it's fine.
Awesome. And the second question is, what's Kevin's thoughts on Coinbase Agent Kit for EVM chains and scaffolding? Does he have a suggestion for multi-chain support, engage Solana, etc.?
Yeah. The agent kit stuff is great. Huge fan of the agent kit. A huge fan of Base. Like they're just making some amazing stuff. They have their MCP server that they just released as well, which is really cool. Yeah, so I think for like multi-chain stuff, right now that's the go-to would be like Base Agent Kit. There's some other, like Privy, I think also might be toying around with some Solana stuff. I will tell you that we are going to be adding Solana support soon to OneClaw, which essentially should put us on par with like Coinbase Agent Kit. We also have embedded wallets, and we are going to be adding smart account wallets as well, hopefully here soon. So yeah, I think for the time being, yeah, I really am a fan of everything Base is doing. We're like partnered with them, and we really like working with them. So we'll continue to try to do that. But yeah, Base Agent Kit is really cool.
Awesome. And last question for now: does this methodology implement zero knowledge proofs, systems, or in any way?
Yeah, good question. Yeah, so zero knowledge proofs are super awesome. We're not using them yet. I think it's something that we're going to explore, mostly for like reputation. So one of the things about agents in this day and age, like agents are kind of like autonomous, software that's just kind of like operating independently. And so there is some interesting concepts around proving identity of a particular agent. In other words, like if this particular agent is operating on behalf of another human, how do we prove that? And like, something like a zero knowledge proof would be super valuable for that. There's some existing platforms that are already doing interesting things there that we're going to either integrate with or try to adopt similar methodology. But yeah, the ZK stuff is really useful. We're not using it at all. We are doing some like attestation level stuff that we haven't exposed yet, but eventually you'll be able to like have attestations, which are essentially signed kind of proofs in a way using OneClaw. So we'll sign things in the TEE that will like prove maybe an agent's identity tied to a user's KYC or something like that. So we're thinking about adding some ZK stuff, but nothing yet.
Awesome, thank you.
Yeah, no problem. These are really good questions. You guys are great. Keep them coming.
Good audience.
Okay. So, yeah, good audience. Amazing. I love this. So then for the Shroud, like what does it look like? So we talked about the private keys. For the Shroud, what we have here is we're going to use the AI SDK, and we are going to essentially pass all of our traffic through the Shroud. So you can see right here, Shroud is just an LLM endpoint, and it has the same completion routes as like whatever LLM you're using. So you can kind of think of it, if anyone knows what a reverse proxy is. I used to work for Nginx, so I know a lot about that. But it takes in all the requests over this URL and then forwards them on with the appropriate API key. Now, if you want, you can either store the API key in OneClaw, or you can just pass it as a header. It's really up to you. In this case, you can see we're like passing it over the vault. But this is just, again, it's how you would use Shroud for all that security stuff that we talked about. There's some pages that are already wired up. We'll show those in a little bit, but they're basically like endpoints for you to test with.
And just
a
small stop maybe. If you can expand a little bit more about shrouding, I think it's an interesting topic.
Sure. This one here, yeah.
Like I didn't fully grasp it yet.
Oh, this here, the Shroud stuff?
Yeah.
Okay. Yeah. So if you have an agent on your local machine, like let's say you have Claude code, right? your Claude Code or Claude Desktop is talking with api.anthropic.com, right? If you're using ChatGPT, your agent is chatting with, I think it's api.openai.com or something. So you have these endpoints, right? All we do is we just kind of sneak in there in the middle, and we just allow your AI agent to talk directly to us and then proxy on your request to your provider. So if you pay for Google Gemini, you probably are talking with api.google.com, right? And you need to pass in your Gemini API key. I don't know exactly what the URL is, but and so what we do is we just allow you to route your traffic through the Shroud and then pass on your API key for you. So it's in the term of like proxy, we call it HTTP X forwarded for header. So where we actually like forward a header on to the endpoint. And so all this means is that you have basically three options. You can use OneClaw, which has its own LLM subscription. You can use an existing API key that you already have for your LLM provider, or you can just only use Shroud. So you have like kind of three different ways, or use your own LLM endpoint. So you don't have to use Shroud at all. You can just use your regular LLM endpoint. Okay.
Okay, and two follow-up questions on that. First one, does it slow down anything in any way, or like?
No,
Does it
not
present
really. I
any
mean,
limitations or
of
anything
course,
like that?
a little bit. Yeah. I mean, of course, it's got to make one extra hop, right? This is, this is just kind of like a caveat of having a reverse proxy and having that security layer. So yeah, it needs to go because you can again imagine it's going to one server, forwarding on everything, streaming back and streaming back. So yeah, 100%. It's adding a little bit of latency, but it's not. If you're dealing with AI already, you have like pretty well, it's a pretty latent service as it is.
Yeah.
And that's why you have like the thinking and streaming and stuff like that. But we do support the streaming. So it's going to be fairly unnoticeable, I would say.
Awesome. And the second question is, does it have a parallel in like local LLMs? Let's say I'm running my LLM locally, using whatever open source LLM is available on my computer.
Yeah, that's a really great question. Yeah, so for the Shroud, unfortunately, no. But you could configure Scaffold Agent, which is the starter kit, to point at your local AI. You could just replace the endpoint with the local host. We do, however, have an MCP server that's open source that lets you do some security inspection. It's not everything that you get with Shroud, but it's a pretty good amount of stuff, and it's also open source. So what you could do is have your agent talking to the Shroud MCP, and you'll get some additional security there as well. So you can't really use the Shroud locally, unfortunately, because it's a SaaS product. But we're thinking about maybe open sourcing it soon, where you have like a lighter version that you could run locally. And there's just some work involved with that, but we haven't done it yet. But that might be something coming soon. So
Awesome.
Good questions. Yeah. Okay. So these are just endpoints. We'll show those off in real practice. So you can either run the NPX Scaffold Agent at latest interactively, or you can just use these URL arguments, which is really nice because then it's very easy to automate. And you can also, you can just orchestrate it a lot easier. So really, really, really nice. Everything with Scaffold Agent is very AI friendly, right? Like the idea is AI wants to automate things and not be interactive, right? But if you want to use the prompts in the wizard, you can, or without prompts, you can. So this actually goes back to, this is a good one to understand how Shroud works. So again, you have a browser that you bring up your agent in that goes through Next.js. There's an endpoint for Shroud, which is the trusted execution environment that does all the scoring and the protection, the LLM stuff to secure it. And then you have the provider behind that, and then it goes back to the UI. So it's kind of a stream, and this kind of explains how that flow works, right? The routing. Okay.
Awesome.
So what did we use to build Scaffold Agent? We used Scaffold E2, some stuff from Scaffold E2. We use the Vercel AI SDK. We have a burner wallet, which we'll show off, which is like an in-browser wallet for testing. We use Shad CDN, and we use Just. Yeah, I think we're ready to just show off. This is just showing, yeah, how quickly you can get up and running with just these commands. We already kind of showed this earlier. Yeah, so this is just like what's coming next. Yeah, let's see here. These are just resources. So it's an NPM package, so you can install it from NPM. We have it available on GitHub, which is here. So github.com/OneClawAI, and it's called Scaffold Agent. All the repos for Scaffold for OneClaw are in that same organization, OneClaw AI. There's also docs for OneClaw if you want to dive into that. There's also a website for Scaffold Agents. It's scaffoldagents.xyz. We'll go there and show that off in a sec. There's a help command, so --help will tell you everything that you can do with the command line, which is really cool. And there's a Telegram group that we have. And if anyone's having any issues, you can open up an issue on the repo, and we would be more than happy to help you. Or if you want to provide back to the community and create some features, we would love that. All right, so stop wiring, start shipping. Okay, so let's actually go through. Well, is there any questions at all, or is it good to maybe do a demo at this point?
Yeah, let's see. We have one question, and then we can jump for the demo.
Okay.
Let's see. If Shroud is a SaaS product, can you point out to data usage policy for the traffic being routed through?
Yeah, so if you go to the OneClaw XYZ here, and you go all the way to the bottom, we have like all of our policies here, privacy policy and terms of service, which are on the bottom for oneclaw.xyz. Pretty much the only thing that we log for is stuff that is in the audit log for the agent itself. And this is more just for the user. So like we as OneClaw as a company, we're like big on privacy, right? And so like as an example would be if you go to like the blog here, we do these blogs, right? And we did one recently that talked about private by default agents, and we added support for Dark Bloom and Venice AI. One of the nice things about stuff running in the TEE is, we don't, again, we don't log or like ingest this stuff, or like we're an LLM provider, but we're just a proxy to Stripe's LLM. So we don't train models, we don't track your information. We're big on like anti-privacy, or we're big on privacy. And so we actually prefer that our users use something like Dark Bloom or Venice AI, which has private modes, and we are fully compatible with that. And then we're only logging inside of the logs on what the agent is doing related to the security stuff. So I can show you what that looks like briefly, but if you come in here and you like log in here, you can log in with Gmail or whatever you want. But if we look at like a particular agent inside here, here's a midnight agent. We basically do logging for like all of the agent's activity, which is just for the user. So us as a company, we don't really like use this data other than just to kind of inform the user. And you can kind of see like like let's say your agent does get prompt injected or code injected, right? You're going to see this kind of like issue show up here, and then you'll be able to kind of like look into there. But we don't actually log the LLM request itself. We just log the issue that happened and what exactly happened in that scenario. Hopefully that answers the question.
I think so. or and if not, let us know in the comments. And one more question, I think you touched it before, but if you can maybe expand a little bit more about how it actually works. They asked, how do you restrict the AI from actually knowing your API keys and credentials?
Yeah, we kind of touched on it. So essentially what we do is OneClaw is stores all of the private keys in a hardware security module, and we also support multi-party computation. So what that means is that we store, actually, maybe I have a slide that might explain this a little bit better. Let me just find it real quick here, just so we have it.
Sure.
There's a better slide that maybe talks exactly about how that works. Okay, so I just want to show this slide because this makes sense. So first of all, what we do, we use a hardware security module, which is a physical hardware in Google Cloud. We allow the key, access to that key, to be accessed either just with the HSM, right, by default, or we allow split custody. So what that means is we can, multi-party computation. So what that means is we can cut the key in pieces, right? And we can store half of it in the HSM, and we can give half of it back to the agent. So that's called a 2 of 2 XOR split, right? And so you need to comprise both those keys, right? It's kind of like if you had like a double-sided key, you would need to put it together and then open the lock with that.
But how will it actually look when I'm talking to, let's say, Claude or Gemini? I'm sending it a request, and I'm not, let's say, security aware in any way, and they've sent him the API key to another server, another service. They asked him to do something. Like how, like who is recognizing this is an API key for that, and I need to shroud this specific lines or credentials?
Yeah, for sure. So it's basically these two slides. So this is creating a policy. We can create a policy for an agent. So let me kind of rewind a little bit. So OneClaw has it has two APIs. It has a human API and it has an agent API, okay? So as a human, you're like storing your private keys or API keys or whatever with this particular human key. Then you're creating an agent and you're creating a vault, storing the keys, and then you're creating a policy. So you're kind of like managing an agent, right? And you do that either through the UI or you use the API. The agent then has its own API key, right? And depending on what policy that you create, like this, where we say, okay, well, this particular agent named DeFi-bot has to use the intent, so it can't see the private key. It can only use the private key and sign, and it has to do it with these guardrails in place, right? So when that agent needs to make the transaction, it doesn't actually sign anything. All it does is it goes out to the API and proves that it can use the key and gets back what's called a JSON web token. So the agent has an API key, it authenticates, gets back a JSON web token that basically proves what kind of guardrails that it has in place. So it can say like, okay, well, I'm allowed to execute this transaction inside the TEE. So then the agent submits this intent, right, with the chain to the value and the data, the call data, and the agent sends it into the TEE, not with a signature with a wallet, just with the JSON web token. And then the signing happens inside the trusted execution environment. So it's physical hardware and it gets signed inside that TEE, right? And it can either be broadcasted inside the TEE or it can be sent back to the agent as a payload that it can then send with its own RPC. Does that make sense?
Yeah, much more. Thank you. By the way, your video just disappeared.
Oh, really?
I can see the screen, but not you anymore.
Oh, maybe my camera died. Let me switch cameras. It could be because I was trying to charge that camera. We'll use this one. There we go.
Awesome. Yeah, okay. I can see it now.
Cool. All right. All right. So let's actually. Any other questions at all?
No, I'm excited for the demo.
Okay. Okay. Awesome. Very cool. So yeah, let's actually do it now. So what we're gonna do is we're gonna go to scaffoldagent.xyz, and we're going to grab this command, right? Just copy it. And, there's some like instructions here. It's basically a lot of the stuff that we already talked about here today, but we're going to run this command. Okay, let me zoom in here a little bit. Can you see my screen okay?
Yeah.
Okay, so we're going to run npx scaffold-agent at latest. And it's going to ask us if we want to install this package. You'll say yes. I think the only thing you'll need to have Node.js on your computer, and you'll need to have Just. So make sure you have Node.js installed in Just. And this is also explained inside the repo. If we go all the way down to the bottom, there's a GitHub link right here. I need to make that a little easier accessible. And it's going to walk you through that you need those two things. So Node.js and NPM and Just. So make sure you have those installed. And then it's going to ask you what you want to name your project. So we'll call this Underground. And it's going to ask you how you want to store your secrets. Okay, so this is up to you. You can just do like just a standard env file. You can do an encrypted env file. I want to show off OneClaw because I think there's a lot of value in it. So we'll use this, which is, again, hardware security backed secrets. And it's going to ask you, do you want to enter your OneClaw API key now? And we're going to say yes. We're going to come over here and get an API key. So I'm going to use this here. Let's see. So I'm going to go to oneclaw.xyz. I'm going to sign in. And now this is basically what we see with OneClaw. It's basically it's a lot of different things you can do with OneClaw, but all we need to do is get an API key. So you can see right here, there's API keys. We can click that, and we can generate an API key. You also can look through your agents. I'm going to delete a couple. I'm just going to delete one agent because there's a limitation. You can only have 2 agents for free, and I'm using a free account here. So let me delete this other agent just so we don't have any issues with space. But inside of OneClaw, there's a concept of an agent, right? And there's a concept of a vault. We talked a little bit about that. We're going to dynamically create this stuff with the Scaffold Agent kit. So all we need is the API key, okay? So we're going to come here, go new API key, and we're going to call it Underground. This. And you can create like special rules for the key, but we're just going to do full access, never expires, and hit create key. So we're going to get back a key. I'm going to copy it to my clipboard, right? And I'm going to come over here and paste it in. Normally you wouldn't show that on screen, by the way, but we're going to rotate that key in a sec anyway, so it doesn't matter.
Okay. The corresponding keys we will get through another service is the like the Gemini one or the Cloud one in the same place, I guess.
Yeah, exactly. So the benefit to using OneClaw is that we can put in all of your secrets through this wizard, and they'll all get stored in OneClaw. So you won't need to have them sitting around on your disk. They'll be stored in a secure way.
Awesome.
Now, we need to store at least one private key, though, on the local machine, because the agent's going to need its own API key. But it's not going to be a private key. It's not going to be an API key for the LLM. It's not going to be a straight key. It's just going to be a scoped access key. So we want to password protect that. So this is the one thing that people don't usually realize is even if you're storing one key, you should put a password on it. So we're going to put a password here and confirm it. Okay. And then, so that's going to store that just one key locally. And then now we're going to generate a agent identity. So with OneClaw, what's really cool about OneClaw is we create an identity for every agent. We create a signing key, a messaging key, and we can also create wallet keys for different chains, which I'll show in a sec here, but which is really cool. So we can generate an account identity for the agent, and we say yes. And then it's going to ask us if we want to install ampersand. So I'm not, maybe I come on another time and talk about ampersand, but ampersand is a tool for like X402 payment stuff. And it's really useful if you want to make X402 payments, which is a cool protocol, but we're going to say no to that right now. It's going to ask us what LLM provider we want to use. So again, if you want to use Gemini or OpenAI or Anthropic, you can choose those. I'm going to use Shroud, OneClaw, because I want to show how powerful it is. And we're going to use Shroud as the LLM provider and as the billing as well. So we're going to choose Shroud. And if we wanted to bring our own key, we could. It's going to ask us what model we want to use. So Shroud is not a model, it's just an endpoint. So we can use any one we want. I really like Gemini, so I'm going to use Gemini. This one here, Gemini. And
from curiosity, what's Gemini alias?
Oh, I think it's older version of the LLM. For some reason, it has that old. Yeah, I think it might be like 2.0 or something, Flash or something. I'm not sure. I need to fix that. That could be a bug.
Yeah, no worries.
And then so do we want to provide our own key? So we could just bring our own like Gemini key, and it's going to store it in the API keys in the vault. So API-keys / whatever. But we're just going to use OneClaw. Now, if you come to OneClaw and you go to billing here, you can see here, like OneClaw is free, by the way. It's free for like storing up to 1,000 requests and vaults and agents is free. But if you want to do your billing for your LLM through here, you need to add a credit card. So it's through Stripe. And so you can see here, I have it active. I've already enabled it. You can just bring your own API key if you want, but if you want to use OneClaw as the LLM provider, you need to add Stripe there. So I'm going to use that just because it's simple for the demo. As you can see, I'm not going to have to go, now I don't have to go like dig up a key, from somewhere. I can just use OneClaw. And then the chain. So we're going to show it off so you guys can see what it looks like, but we'll use Foundry. It doesn't really matter which one you choose. If you're not familiar with Foundry versus Hardhat, it doesn't really matter. I would just use Foundry because it's the newest one and it's pretty fast. We're going to use Next.js just because I like Next.js, but here's where you would choose like Vite or Python. And then the very last one is pretty important. This is, do you want to enable the transaction signing in the TEE with the Intents API? So we're going to say yes, because we want to like give our agent a wallet, but we don't want them to ever see the wallet, right? And that's it. So now it's going to bootstrap the entire application. You can see here that it created some wallets. It created a deployer wallet, an agent wallet. It stored the private keys inside of the OneClaw, right? It created an ENV that was encrypted. So it actually creates two. It creates one for non-secrets, which is a .env file, which is actually what .envs were supposed to be used for. But then it also creates an encrypted one just for that one password or the one API key that we need. And it's installing all the packages right now. So that will just take just a second. And once it's done, we'll be up and running. While we're waiting for it, we're going to open up some other windows, because remember we talked about you need a couple terminals open. So after you run through that wizard, it's going to take just a second to like install those packages, right? So what we can do is just split up the screen. So I'm going to split up the screen like this. And I'm using Tmux, but you can just do this by opening new windows, right? And then in those new windows, we want to go into that same folder. So in my case, that was a workshop underground here. Same thing goes down here, CD workshop underground, right? And again, you can just open up new terminals. So if you're on a Mac, you just go terminal new. If you're on Windows, I don't know, because I don't use Windows. But yeah, so here, okay, so what did we get right here? So let's take a look real quick. Let me zoom out a little bit. So we get this little QR code for the deployer account and for the agent. So it creates two wallets and stores them away. these are the public keys. So if we wanted to, we could use our phone to like send some money there and fund them. And it's going to give you like a wizard, kind of like a command for you to type to get started, right? It kind of teaches, shows you exactly what you need to do. So just chain will start up your blockchain. Just fund will fund it with some test funds. Just deploy will deploy the contract and the ABI, generate the ABI types. Just start will start the front end. Just ship will publish it to Vercel, which is really useful if you just want to like push it to Vercel. And then if you need to regenerate a wallet, you can do just generate and it will generate another deployer wallet. You don't need to use that. I probably should get rid of that. So let's just start doing these commands. So first we'll do just chain. Okay. Oh, and by the way, before we do that, actually, let's go back to OneClaw and we'll see that it created the agent here. It created underground agent, right? And it created an underground vault. And if we click the vault, we can see the secrets are in there, right? These are the 2 private keys. And the agent never even has to like see them. You're just going to be able to use them inside the TEE because it's configured here with the Intents API, okay? So let's go back real quick and just start this up. So again, we want to start up a blockchain locally with just chain. And that's going to be really fast. You can see it's listing on 8545. Then we're going to come to the second window here, and we're going to do a just fund. So now that we have the chain running, you can see here what we did is we just deployed some funds from the chain to the local, to the 2 addresses. So we gave some to, well, mostly to the deployer, actually, I think. We deployed some funds so that we can deploy the smart contract. So by default, that that deployer account that we create, it doesn't have any funds on it. So we need to fund that. So we did just fund, and then it would kind of like airdrop some funds for us to toy around with. Now we can just run just deploy. And it's going to ask us for that password. So earlier when you need 1 API key to unlock the private key. So we're going to do a password here. There we go. Okay, so that was successful. And it was deployed. So we got the smart contract was deployed here. So we did just chain to start the chain, just fund to fund that smart or fund that deployer account, and then just deploy to deploy the smart contract. And we'll show off what it looks like here in a second. And then the very last part is just start. Same thing, it wants the password, so we need to put our password in. There it goes. So now the front end is started as well. So we have the chain running here. We have our front end running here. And now we can go to this website and look and see what it looks like. Okay, so let's go there. So it'll take a second for it to compile, depending on your computer. So you see here it says compiling /. And we have some blockchain activity here. You can see there's some ETH calls happening, and we got the header. There we go. So that's it. So now we have this AI agent that essentially we just created. And it's a very basic kind of chat interface, and we can chat with it. So we can ask any question. So we can say like, what is pi to 10 decimal places? Make this a little bigger. There it goes. So it kind of is, again, it's a very basic kind of agent, but it's great starting point, especially for like a hackathon where you're just like kind of innovating and you want to start like making changes from here. It's just a good starting point because we have our private key. And by the way, the agent has a private key, right? So we can go there. So there's all these links on the top. Well, first of all, what we notice here is, see right here, we're automatically connected with a wallet. And if we click it and disconnect, we'll get a connect wallet modal. So we get this little pop-up. So we get this cool thing called a burner wallet, which is basically like, it's an in-browser wallet. And it's not secure at all. You only want to use it for testing. But if you just click that, you have a wallet. So you can see here, we're connected. And we have this wallet. It doesn't have any ETH right here, but there's a little faucet button right here that lets us click that. And there it goes. It sends us 10 ETH. And now we have 10 ETH in the faucet. So it's kind of like a little burner wallet that allows us to get ETH. We could connect our MetaMask or Rainbow or Base or whatever we want here. But the burner wallet is just for testing. You know, at some point when you finally like deploy your agent to like Base, you probably want to use like MetaMask. You don't want to use the burner wallet anymore.
Okay,
Does that make
and
sense?
what's the like most common use cases to use this, by the way? Just like give us some ideas.
Yeah. Well, we can try to do something actually. So let me go back to the burner wallet here. So we have this agent. If we ask it like, what is my balance, right, on Ethereum mainnet? Let's just see if it has a balance. It's probably not going to be able to know, right, what the balance is. So I can't directly check your balance without knowing your wallet address. So maybe I can provide it. Let's see. Copy the address. This is my wallet address. What is my balance? So we probably want to think about like what could an agent do on chain that's interesting. So it's not going to work, but let's see if we can get it to work actually. And we'll try to add like a small feature maybe. Let's do something here. First of all, let's come back to the project and load it up in Cursor. I'm going to answer your question, but give me a second, and
No
I'll
worries.
kind of yeah, because I think your question is super interesting because we have all these cool tools now, right, to build really cool stuff, and it's like, okay, well, what do we build, right? And I'm going to give you some ideas. We're going to try to build something actually real quick and just using AI. So first of all, we have this. It's not really working well. It's not really giving us the balance and stuff like that. So I've loaded up the project in Cursor. So if anyone hasn't used Cursor, Cursor is like a, it's a fork of VS Code, which is just an editor, but it has a chat, right, that we can just like try to ask questions with, right? And we have the entire project here. So I'm just going to tell it like, hey, make this work. First, I'm going to let it do its thing. And I'm just going to see if it can add like some endpoints for me to be able to check my balance. And then while it's doing that, we'll kind of brainstorm on some ideas on like what we could build here with it. And while it's doing that, let me just go ahead and come over here to packages. Okay, so we talked about this earlier. There's two repos. There's the Foundry repo, and it has this source right here. Okay, and you see inside source, there's an agent wallet.solidity. So this is a Solidity file. One of the things that I think is quite interesting about on-chain agents, like everyone's thinking about on-chain agents in the terms of like DeFi. So one popular narrative is like, well, you want to give your AI agent a wallet and you want it to be able to make trades on your behalf, right? So maybe you wake up in the morning and you're like, hey, like Mr. AI agent, I want you to go and find the best return on investment for like, $200. And then it kind of has some programmatic way to look and see what's available. It sees what trades are going on. Maybe it copies other traders that are successful. Maybe it's like sucking in some data. You can kind of start to think what I'm talking about here. Like you want to build like an agent that has very, very smart like understanding of maybe like crypto markets and access to these data points and stuff like that. And you almost like think of it like you're writing software, right? You need to like think about how the agent is gonna reconcile on your like natural language question, right? You're gonna say, well, I want to make money today, and I want to make $200, or I want to make, I don't know, I want to double my money. I want to make $400 out of $200. What's the best strategy? Then you have to think like, well, how do I get the agent to do that, right? And one of those ways is like just by using existing DeFi tools like Uniswap or LiFi, or these like swaps. Maybe you could do. Maybe it finds like recently launched meme tokens and swaps into them. I don't know. But maybe it's a mix of things. Maybe it's like half of it is DeFi, so it takes $100 and it puts it in like Uniswap and swaps for stuff and monitors it for you, automated and checks for you. But maybe your agent has its own smart contract. And this is where I think is quite interesting, where one of the narratives I talk about is agents have wallets, but agents can also have smart accounts. They can have smart wallets that are programmable money, right? So maybe you kind of come up with a weird way where your agent has an exposed contract to do something new and interesting, right? And this is where like a lot of innovation I think happens with crypto is in the solidity level stuff, right? So what we get here with this starter kit is a starter smart contract. It's just a very basic smart contract. It's kind of an agent wallet. And we can extend this wallet to do whatever we want. And we can deploy it wherever we want. So we could deploy it to base mainnet or Ethereum mainnet very easily. And so I would, if I was first like starting out this thing, I would come in here and look at the wallet and say like, okay, well, how can I program and make my agent smarter with its own smart contract, right? And maybe how can I make money with my smart contract? Like maybe this is a take on a DeFi protocol and a new thing. So first I would look at that. Then I would look at like X402. Has your community looked into X402?
Yeah,
Have you done any
we had an
sessions on
event
this?
about the X402.
Cool. Yeah, so the X402 is really, really useful because X402, for anyone new, doesn't know what X402 is. It's basically for you to monetize an API. And so with Next.js, we have this Next.js folder right down here, and we have the app sitting right here, and we have an API, and we have the ability to make programmatical endpoints inside of our agent here, and we could easily monetize those with X402. And so let's say you have an agent that is you personally are using your AI agent to do trading and do all this stuff, and then you want to like sell that information, right? You could create a special API endpoint in here that is, I don't know, like slash insights or something like that, and it kind of has up-to-date information about like what's going on in the industry and what a good trade would be or something like that. So using X402 in combination with maybe like writing smart contract logic for your agent, and I think in the future we need to think of the AI agent as an individual, because the agent's going to have its own wallet, it's going to have its own smart contracts, it's going to have its own API, it's going to have its own memory, like all these things that we as humans like use every day. It's going to have its own way to communicate, obviously. It's going to have its own voice. It's going to have its own image. It's going to have its own organism, like acting organism. It sounds so weird to think.
Yeah, that's cool.
Huh?
It's it's actual an identity for agents. It's cool.
Yeah.
I had an idea. I'm not sure if maybe it's a bit too much, but like, is it possible to connect, let's say in this framework, an agent and to hard code into his smart contracts, say more advanced logic to do more complex things that is currently very hard to do, like creating a custom-made insurance for basically anything. That's one of the like use cases I thought directly of when I saw this now. But like
insurance.
I can give I don't know, give an agent, I don't know, $100, let's say, and tell him to give those $100 to the person who was insured by basically anything, and he will have the logic to decide if this person deserves 100% compensation or maybe less. But that way I can kind of do it for more people, but maybe that's the problem of connecting many people to this one agent. So
yeah, that's an interesting one.
Just brainstorming with you live, but like
let's try it out. Let's try it out. So I want to turn this agent into an insurance broker with depositing some ETH for coverage and allowing people to purchase coverage via the smart contracts. Let's see what it can do. I mean, it's pretty cool. Yeah. And then we can also make sure the UI is fancy as well. Let's see if it works. So this is a cool idea. Like, you know, so what I think what we said is like, okay, well, let's use this like wallet infrastructure to basically. Thank you. Yes, my son walked in. We're going to use this wallet as kind of like a way to do monetization of insurance. So we'll have like a special insurance kind of offering here. And then, yeah, people will be able to like probably submit claims. The question is like how we make it so the AI automatically decides. That might be a little trickier, but let's see if we can at least create the smart contract first. And then while it's doing that, let me just show off the UI. So we already talked about this faucet here, but there's also this balances endpoint, which is going to tell us what our balances are on each of the wallets. So again, the agent has a wallet, which is locked away inside of OneClaw. That's this one. The wallet that we're connected with is here inside the browser. It's this one. And then the deployer is also not shown here, but that's the one that we use to deploy the smart contract. That one's locked away in OneClaw as well. So we can check the balances. We can also, this is just kind of like a suggestion. This is the ENS endpoint. And if anyone's not familiar with ENS, it's Ethereum name service, which allows you to like give it your agent kind of a name. We're going to add more stuff here, I think, in the future. Right now, it's kind of very basic, but it just kind of urges you to like register an ENS name for your agent. And then also we can have a direct link to the identity page here, which allows us to register the agent with ERC 8004. For anybody who doesn't know what ERC 8004 is, I briefly touched on it earlier, but you can think of it like a public registry of your agent, like what ports it listens on, what services it has available, what its name is, and then you use that to kind of like build some reputation, right? So the minute you deploy your agent to a public network like Base or Base mainnet or Ethereum mainnet, you probably want to register it if you want to make other people aware that it's available. And this is how you do it with this kind of like thing. You can just come here and register on chain, and it will help you do that. We're on localhost, so it won't let us do it. But if we were on a special chain, we would be able to do that. That's supported. That's cool. Yeah, really cool. It's kind of like, you can think of it like a passport. You know, you need to register to be able to travel. You kind of need that for that. This one is the swarm stuff. We won't really show that because we're only using one agent. The last one's the debug tab. The debug tab is kind of cool. It's going to allow us to check what chain we're on. I don't know why this is giving an error, but anyways, this is the wallet and the agent. So this is the smart contract that we deployed earlier, and you can see it doesn't have any balance, and it's listening on localhost. And then there are this UI I need to clean up. It's not really super useful, or it's not super easy to see. But basically you can read values from the contract. So you can see here, there's these values. I need to fix this so it's a little easier to read. Oh, it already deployed it. You see right here, insurance broker. It already started to deploy everything. This is great. So you can see like it's built a whole smart contract already. Let's come over here and look. It's still going. But it did deploy it. So all of your smart contracts are going to show up here so that you can look at them visually, right? And it will let you read from them or write to them if they're write functions. So you see where it says write and it says read. These are read functions. This is hard to read. I need to do some work on this and make it look a little better. I'll try to do that today. But this thing is just chugging away right now. It's building your insurance application. It's almost done.
That's awesome.
Yeah.
I've heard they just got bought by Elon Musk, but I'm not sure if it's true.
It is true that they have like a 1-year cliff that I think like up to a year, like to basically finish the deal. I don't know exactly what the stipulations are, but it's pretty awesome. Good for them. I really like Cursor a lot. It's my favorite. So
Definitely.
okay. So any other questions while we're waiting? Anything you can think of?
Yeah, we have one question from another question from Oren. He asked if we can authenticate the agent through OAuth instead of API key.
So not yet. That's something we have had people ask before. The only thing I'll show you real quick, if we come to register agent and we create a new one. Okay, we do also support OIDC credentials, and we also support MTLS. So the thing about the OIDC is you just have to have like the issuer URL, the client, and the client ID, and then add that here. And then this will do the JSON web token assertion. Yeah. So this has not been tested, but if you have issues, please let me know. And if you have any problems, because I have not personally tested this integration, but I think we have some users that are using it, so it should work.
Okay, awesome. So Oren, if you're trying that out, let us know, and you can find Kevin in our group as well.
Yeah. Okay, so it's done. Cool. So I'm just curious. Let's see what it actually built. / insurance. Nice on-chain coverage. So it kind of built out like a new smart contract here, which is like insurance broker, policies, policy types. So you can see how easy it was to kind of just use AI to like use Scaffold Agent as this kind of starter kit, and it kind of like went wild here. 229 lines of code, and it deployed it, and it's working and available. So then maybe the next question is like, how can I test this with my AI agent? Let's see. Around deploy. Okay, I deployed the with 10 ETH. So it deployed it ran the, oh, it's already run it. Oh, we need to redeploy it. No, it should have already deployed though. I think it deployed it for me. I think it deployed it actually.
It's so cool that it works so fast. I think like to try to do this demo even a year ago or 2 years ago would take like.
I know, right? I know, right? All right, let's deploy it again to make sure. Oh.
10-hour webinar just for you guys.
Yeah, we're just vibing. Yeah, it would have been forever, right?
Oh yeah.
I need to install something new, so let me install that real quick, and then it should be good. Localhost 2000. Okay, let's see. Purchase a basic coverage. Oh, cool. So we can just like ask it to purchase a basic coverage policy for 1 ETH. Nice. Find a claim on policy 0. Nice. Okay, it's installing some packages, so we'll give it 1 second. Actually, we can try this while we're waiting. Let's see if it works. Come back to the agent. Come on. Let me restart everything real quick just to make sure. Oh, it's still installing the UI, so we got to give it a second. Yeah, okay, now we go. All right, just start. Let's try it one more time. Oh, that's weird. Let's see, we have some kind of issue. Let's see if it can fix it real quick. So it looks like it might have added some kind of weird thing. Oh. So yeah, what nice thing about Cursor is you can just kind of drop your error in here. And if you haven't used Cursor before, down here on the bottom we have like the model selection.
Maybe it's still blocked, I guess. But like
yeah, unfortunately, yeah. Oh yeah, I think it's because I'm in the US, right? That's so annoying. Yeah. This is why private and decentralized AI is the future. Yeah, so Opus 4.6 is what I've been using most of the time. And it usually is pretty good. Like, if you want to save a little more money, like Sonnet is also pretty good. But it does make mistakes sometimes. If you want to like, yeah, spend more money than Opus 4.8 or obviously Fable is also really good. So it looks like it introduced some issues with the front end, but we're gonna give it a second here.
Yeah, no worries.
Oh,
I think it's very useful for most of us here to see how you're dealing with problems live. I guess I'm
yeah.
not the only one who is like jumping between different windows to try to debug things. We're all dealing with this today, so learning from how you do it is also valuable.
Oh yeah. Yeah, so definitely it can be hard to troubleshoot. So you can kind of see here, it's good to like keep it. This is not the reason I like Cursor, is because we can really keep an eye on what's going on and what it's telling us, and you'll start to be able to read and see like things as you start to, in this case, it's trying to use a different version of Node version manager. Sorry, Node.js with NVM, and it's failing. So it's quite interesting. Let's see if let's see if this actually loads. Nope, let's see. Oh, it's updating Yarn as well, which is fun. We're not actually using Yarn though. We're using NPM. So it's quite interesting.
What is Yarn, by the way?
Oh, Yarn is a package manager. So yeah, I think that's what happened is it asked to install Yarn. So we actually need to use pnpm. I think we're using pnpm. Let's see. Yeah, I think we're using PM. So that might have been my bad. I think I might have should have used the bug. So Yarn's a package manager. Scaffold ETH uses it, and so it's got kind of habit for me to like check Yarn install. There we go. Now it works. Okay, so now let's go back here and see.
Okay, ready everyone.
Yeah, we're ready. Oh no, it crashed again. What the heck? Oh no.
It is how it is to build.
Yeah, so I'm just gonna tell it we're using PNPM to make sure that it's not trying to use Yarn still. I feel like it's trying to. Yeah, got it. Okay, so yeah, it's gonna remove Yarn. That's good. So yeah, PNPM is a little bit faster. So I usually recommend, yeah, PNPM. Some people like Bun as well. That's another one that's really good. It's pretty fast. Yarn is kind of slow and buggy. But Scaffold ETH uses Yarn, so I use it often, unfortunately. But PNPM is pretty good, and so that's why when I built Scaffold Agent, I made it PNPM.
Nice. In the meantime, while we were waiting, if you want to like tell us a little bit about what tools you're using today to make your life as a builder easier.
Yeah, for sure. Yeah. So I've been using a lot of different AI tools actually. So I'm using a combination of like my flow is usually I start out in Claude, Claude Desktop. I really like Claude Desktop because you can kind of give it a lot of context when you like start a new kind of thought process. If you come down here to where Claude is and you choose the effort and you put it in thinking, and I usually do high, which is just fine, for speed wise. And you can ask very, very like complex questions and like give it lots of links, and it will go out and like do a lot of research. It's kind of similar to ChatGPT deep thinking, which is also really good. But again, I like Claude because, well, I've been using a lot of Anthropic tools, and so I think they're really good. And so you can see here, like I kind of keep track of all my chats that I have with Claude on like different solutions and integrations. So I'll ask a very complex question, and I'll give it a lot of links, and then it will come back with me with some information. And then what a lot of times I'll do is if I'm like going to bootstrap and start a new application, I'll say, okay, now give me a prompt for Claude code, right, to build this as a prototype. So then I'll get it back a prompt from Claude Desktop. Then I'll come over here to Claude Code, and I'll make a repo and then run Claude Code. So like, example, if I would did like a demo directory here, that already exists. Let me go into the demo directory, and then I have this kind of simple thing here. Let me make another one called example, and then I'll come in here, and then what I'll do is I'll load Claude like on a command line, and I'll just dangerously skip permissions with this command line. I don't recommend this for everybody, but because this is going to completely just let Claude work and build something out. But I only do this once, so I do Claude dangerously skip permissions, and then I paste in all the chat. So I say yes, I trust this folder, and I paste in that entire context that I got from Claude Desktop here, and then it will bootstrap the entire application without bothering me. Then I can come back to it later in Cursor, and I can see what it built, right? So I use multiple tools and kind of chain off of them, and that's kind of my flow. And what I've found is really, really
And they're
useful.
all connected already on your computer? Everything is local?
Kind of, yeah. So Claude Desktop is not local. Like you run everything in the cloud. And so that's why I just use it for like ideation, and I have access to it on my phone and stuff like that. Here, yeah, it's just a local directory. So Claude Code allows me to just create this, folder, and then I just load it up in Cursor, right? I can load it up in Cursor, and it's just, the same thing essentially. And then I can start browsing around visually and see what's inside the project, right? So like, as an example, like the other day, I'll show you real quick. The other day I created this agentic commerce kit. Where's it at? It's in Xflow 2, I think. No, it's in, where did I put it? CD Scaffold Xflow 2. Yeah, okay. So the other day I built this thing, this agent commerce kit, right? And I prototyped the idea with Claude Desktop. I built it out and scaffolded it out with Claude Code. And then I used Cursor to like see what it built and then kind of like fine tune it, right? And then I start using, if I'm gonna like continually improve the project, I'm gonna want to see exactly what it's doing, right? And so this is actually a fork of Scaffold Agent, right? I use Scaffold Agent to build this entire thing, and yeah, it built it out. And so that's the other thing is like if I'm gonna build something, I'll try to use existing starter kit like Scaffold Agent or Scaffold ETH or whatever it is, and I'll kind of give it some guidance as well. Okay, I think this should be ready to test now. Let's see if this works. Okay, there we go. Let's see if it works. Okay, there we go. So then we can like try to ask the agent, like, what was the thing I was gonna ask? We're gonna ask what insurance policies are available. Oh, we can try to buy an insurance policy. Oh yeah, here, what policies are available? Let's see if it works. So what policy types are available in the insurance program?
Let's see, maybe we'll build a cool product.
Yeah. Maybe we'll become millionaires on it. I wasn't able to find get policy types functions interest broker country. Let's double check.
I think it's because of the
maybe
typo
yeah.
at the end.
No, it should know, but I think let's try this here. Fund purchase. Let's try this. Let's try this. See if that works. Probably need some tuning. We probably need to give it. If these don't work, then we can. I'll show you what I do. Is I just like copy paste the whole chat. Oh, it's not deployed properly. Let me make sure it's deployed. Oh, that's weird. Oh, why am I doing deploy? just deploy. I keep doing that. It's like bad comment. What?
I have to say, it's one of the coolest names for for projects. The Just.
Just, yeah.
Kind of
Oh,
good
it doesn't
name.
have fun. Just fund. Oh, here we go. Just deploy. So I have to fund the account, then I deployed. There it goes. Now it works. Okay, now let's try it again. Fund the insurance pool with 5 ETH. Let's see if that works. So we needed to deploy the contract. Oh, there it goes. Can I help you with that? I will send 5 ETH to the insurance broker at this address. Yes.
Oh,
Cool.
super.
So pretty cool. Yeah, we created an insurance salesman, an agentic insurance salesman. There we go. Oh, they got an error. Intense. Oh, yeah. So because we're using localhost, so what we could try to do actually is we could try to deploy this. I know we've been going a while, but we're doing everything local, and so at some point we probably want to deploy this to like base Sepolia or something like that. What's cool about this command here? So if we go back, let me close this out. The just file is here. That walks you through all the different commands. So how to spin up the chain, how to fund the contract. And if we look at the deploy has these arguments. So you can just deploy to whatever contract you want. So you can do just deploy -- network Sepolia -- network base. You can deploy wherever you want. And then inside of here, there's also a scaffold config that has the chain as well. So see how here's this local host. So we could deploy just by doing just deploy -- network base. And then we could update the scaffold config here from localhost to base. And then instantly our agent is talking to base, which is really, really cool. We can actually try it. Let's try it real quick. So in order to do that, we need to fund the account. So we're going to do just account real quick. Just accounts. Sorry. There we go.
Can we do it with testing fund, or we need the real fund?
You can do it with testing funds, but I'm gonna it's easier to do like production. So I'm gonna just scan this and send some. It's just easier. I'm gonna send some base ETH. So let's go to. Let me find a wallet here that I have some funds. Here we go. You don't need much. That's the wrong one. No. Go back. We're gonna use this top one, and we're gonna send. We only need like, I don't even know, like less than probably 10 cents. I'm just going to send 10 cents. And because it's so cheap to deploy a contract on base. Okay, we just sent some funds here. So we could do.
If it will be more, the next beer is on me. No worries.
Yeah. Nice. So we could do just, is it just balance? Let's see. No, we don't have that, unfortunately. Well, let's check. Let's go get base scan for this contract address. So we're going to go over here to base scan, and we're going to type in the address here, and we're going to go to balance. There we go. We have 10 cents, right?
Nice.
So now we just need to do just deploy -- network base. Put in the password. Okay, we got an issue. Let's see. Let's see if we can fix this. So I'm going to grab whatever this error was, and I'm going to put it over here. So trying to deploy with just deploy -- network base. I got it. Could be something with the intents API. No, it should work actually, because we're actually using. No, because we're just storing the private key. Oh, it might be because the intents is enabled. Oh, it wants 10 ETH for the fund pool. Oh yeah, we need to lower that. So it was trying to send 10. Yeah. Maybe we need to disable that fund pool.
Awesome. It's good that it's recorded because I have a lot of things to go back to later.
Yeah. That's an interesting one.
And I
That's
hope you
funny.
guys are also taking notes. This is we're actually doing this in production. Thank you, Kevin.
Yeah, we're doing it in production. Let's do it. Yeah, maybe let's see if we can get it so not send the let's do a much lower amount. Maybe $1. Let's see. Where's the ETH so we can test? If it was testnet, I probably have that much testnet sitting around somewhere, but not on mainnet. I'm not that, not that YOLO. Yeah, so we can then send a little more money then. So what we'll do is we'll send, so we'll bring the QR code up again, and let's send like $1, I guess, worth. We'll do, $1. It's not too bad. I've wasted dollars on other stuff, Okay, now we'll try it again. Okay, let's try it one more time. Dash network base. Oh, nice. It's working. Sweet. All right, so it deployed successfully. So then what we can do is we can change the network here to base. Save it. And yeah, cool. So now let's see if it works on base. So I'm gonna refresh real quick. And let's say, let's see, what was the last question I asked? I asked like, I shouldn't have refreshed it so fast. But let's ask it to purchase a policy. Let's see if we can purchase a policy for, I don't know. Actually, we might have to convert here. ETH to USD. Let's see what it would be. Actually, maybe that's something we can do in here. No, I need to add those helpers so that it's easy for me to just do that. We're going to need to convert what this is. So let's do $1. Let's do 50 cents. There we go.
Nice.
So we're gonna do 50 cents of ETH. Okay, so we're gonna say like, I want to create a purchase policy for this much ETH on base mainnet. Yes, that's yours. His name is Servine. Yes. Pokemon.
Totally great. Yeah. I was a big Yu-Gi-Oh fan.
Oh yeah, nice. My kids are obsessed with Pokemon right now. Oh, that's weird. So we did deploy it. Well, what contracts are available? It should know what they are. So one of the things we do is we kind of keep track of deployed contracts. So here we have, oh man, where is it at? It's
in the insurance
under,
program, maybe?
no, I don't think so. Out, this is the output. It's here. Contracts public. Oh, here it is. Network definitions. No, that's not it either. Let me just double check. I might have to ask AI. Let's see. So this is where we define all the networks. And I'm pretty sure we already have base here. Yeah, base is listed. So that should be good. It's just a question of, where we have the deployed contracts. Let's actually ask it. Oh, here we go. Agent wallet, insurance broker. Okay, here we go. Insurance broker. So we'll see that. So it's working though. That seems good. 8453. That's base. You selected the insurance broker, which I would like to. I'm just going to ask it one more time on. Boom. Oh.
Should we tell it like what do we want to do insurance on?
Yeah. Let's see. Calling. Well, let's look at the contract real quick. I mean, this is definitely insurance broker. get policy, claim, cancel policy, approve claim, file claim, purchase policy. Here we go. We want to purchase policy. Oh yeah, so what purchase policies are available? We need to find out, yeah. We might have to redeploy the contract actually, which is really annoying because I don't know if we set the right prices for the policy to test. A cheap policy, let's say. Let's just see if it can automatically like figure out a policy to buy, which is interesting. Let's see if it's able to do it. But you can see it's pretty cool, right? We were able to build this agent pretty lightweight.
Yeah, it was super fast, I think.
Yeah.
Even to get to this stage of like testing things and making this work is. It looks like there was an issue with the simulation.
Let's see if we can just send all this code to the chat and just see like, can you help me test? What do I need to ask to test? So let's see if it can give me like a prompt that should work. And if not, then we'll kind of stop. I know we've been going a while, but yeah, hopefully this is valuable to people and kind of people see that.
At least for me, yes. I really hope the audience agrees with me at least.
Nice, awesome, yeah. This is Scaffold Agent doesn't know what insurance broker, so it can't construct the right call data. Okay, one class signing key isn't set up for base. It should be.
As an infrastructure question, like, is it smarter to put another agent in between you and the agent that is on chain, just to translate what I want in free language to like specific commands?
Yeah, that's really cool. I mean, I think the idea of like multi-agent architectures and using agents against each other, not when I say against each other, like fact checking each other and verification and stuff is quite interesting. Yeah, I think it's really cool. It's one of the strategies I think that we'll probably use at OneClaw for like security stuff soon. Almost like having like red team agents that are kind of like constantly auditing what's going on. And you'll just talk to like the red cloud, red team agent to make sure that, your code is not malicious or, prompt injections aren't happening, or maybe it's like constantly running some kind of service that's monitoring, access. So yeah, I think agentic workflows are going to be very similar to like cron jobs, but even better, right? Yeah. Well, yeah, we can try one more read get policy with ours. Oh man, this is we probably would want to fine tune this agent, but
yeah,
for the most part,
in high level, because I don't want to get sucked into that too much, even though it's still fun. So in high level, the next few stages for like to making this work is continue to iterate it a little bit with cursor and Claude, I guess, until you see every time one thing works and what breaks next, until you get to the point that it's working well.
Yeah, exactly. You just like keep chipping away on it. Use cursor, be like, hey, make this better, make this easier. Probably the next thing I would do is make the UI more custom and stuff like that, and building out that. But yeah, overall, yeah. So I hope that was helpful, and I appreciate you having me on. Yeah, it's great.
Yeah, thank you so much, man. So I think now we're at the last part of the event. Do you still have more slides to present or anything, or we can go to the Q&A?
I think I'm good. We can take Q&A and see if there's any other. Yeah.
Awesome. So first of all, this is the time for you guys at home to send us questions for Kevin, and feel free to send it in the chat or in any of the live platforms that is broadcast on. We can see it here, and I'll start with a few questions that our team made. So just a sec. Okay, so usually you have like the usual questions that we like to ask guests. So I'll start with those, and then I'll dive into a few of the more technical questions, maybe. But yeah, can you take us to where you started your journey in Web3? Like what initiated all of it? Where is your story starting?
Yeah. I started out, it was probably the boring answer of like being a trader, like actually buying crypto. I remember I had been like, purchasing crypto over the period of, a few years, just kind of like casually, and then Ethereum like just started doing really well, and I was like, this is something special here, and I didn't really know what Solidity was, and I didn't know what smart contracts were, and I obviously knew what cryptography was with my computer background, but I started getting really into the weeds about understanding like programmable money and how like powerful Solidity is, and I started writing smart contracts. This was right around like before COVID, like right around COVID
Mm.
time, and I found ETH Global hackathons, and I found Scaffold ETH, and I found Austin Griffith. If anyone doesn't know Austin Griffith, he's a great guy to follow. And just in general, like kind of just fell down the rabbit hole of like, wow, this is like super powerful concept of like programmable money. And even today, right, like that's the thing that I think is going to be really valuable for the next 5 to 10 years. Is like banks and real world assets, and everyone's trying to get involved in crypto now because it's so powerful, and I think that it's all about programmable money. So that was my foray. And then I ended up working with Austin, which was a dream come true, to be able to support Ethereum devs, and now I'm trying to focus on security stuff too. So good times.
Awesome. What did you study before then, by the way?
Yeah, so I studied networking, some computer science stuff. Mostly, I actually went to art school as well, which is so funny.
Really?
I went to
Oh,
art, yeah, I went to art school for a while. And so, I also, for a while when I first came into crypto, I was doing photography actually. So I would shoot photography for ETH Global hackathons, and I would also shoot, like, I shot the Bitcoin conference, and I was doing it for fun because I've always been like into like art and design and stuff. But I went to school for computers, and I built my first computer when I was like 7 or so. So I've been doing it forever. But it wasn't really until like trial by fire when I started working at Yellow Pages. I was managing production applications there, doing site reliability engineering, and that was my real school. 3 years of like heavy, like managing applications at a production scale for like a huge company like that was challenging, to say the least. So I would say that was where I learned most of what I know today.
nice. So you started your like your career at white paper, yellow paper, and then what you did next? Like what's
Yeah,
the
so I was yeah. Before I was at Yellow Pages, I was in the Geek Squad. If anyone knows the Geek Squad, they drive around in
no?
the
But
little
it's a good
Geekmobile.
name.
Yeah, so we have like Best Buy here in the States, and then there's the Geek Squad agents, and they drive these little cars. I was working there, then I got a job at Yellow Pages, which is like like kind of like like an advertising company. And at Yellow Pages, I was managing all of the Nginx instances. Like I was the kind of like the administrator for the DMZ, demilitarized zone for the proxy. And so I was really into Nginx because it was so powerful and awesome, and I was pretty knowledgeable on it. So I went to a conference in California called Scale, which was the Southern California Linux Expo, and Nginx had a booth there, and I was like, "Oh, what? Nginx has a company? I thought it was just an open source product." And I met the team, and then we started chatting, and I kind of stayed in contact with them. And about 6 months later, I ended up getting a job working for Nginx, and that was when I moved to Bay Area, San Francisco, and really started kind of diving down the rabbit hole of infrastructure.
Awesome. And when did you join Agent Node?
Edge Node, so it was probably about, oh, it's been 3 years now, actually. So I just had my 3 year anniversary.
Oh, congrats.
Um, Thank you. Yeah. I started doing like some Ethereum build guild stuff right around like 2001. And then, yeah, like I think 2003, 2004, end of 2003, I started doing stuff for the graph. I actually started doing. We had like an advocates program, so I was kind of like a volunteer, and I would do just kind of volunteer work, and then I met the team, and Simone, my boss at the time, was like, "You should come work for us full time," and he hired me. So I've been there, yeah, for 3 years now.
Awesome. Thank you so much, man.
Yeah.
Next thing, what is your favorite thing today about what you do?
Yeah, helping people, doing this kind of stuff is actually my favorite. Like bringing on new users and like, helping people has always been very, very big point of what I like to do. And, it's very rewarding to help new people coming in the industry. I know when I first got started, it was like so hard to figure out like what tools to use and where to go. And Austin Griffith really helped me a lot because he built this awesome thing. So I've been trying to just, replicate what Austin is as much as possible because he's great.
Awesome. Few technical questions and then for final remarks. So, um, the question is about the new attack surface. So traditional smart contract security focuses heavily on code audits and reentrancy. When an autonomous AI agent is, maybe you know what, I'll put it on the screen. It will be easier for both of us. Just a sec. Okay. New one. Okay, that's good enough. So, traditional smart contract security focuses heavily on code audits and reentrancy. When an autonomous AI agent is the one initiating the transactions, how does the fundamental threat model shifts? What attack vectors aren't used in like thinking about?
Yeah, well, I think the traditional like security attack surface for smart contracts isn't going away anytime soon, right? I think that's still very, very important, and if anything, more important. With like Mythos 5 and Fable 5, and the power that brings for like trying to identify these things ahead of time, and protect against these kind of things is super critical. So I think smart contract security is like always going to be very important. Using AI to help, but then also like human interactions too. Like I think it's super important. But I think when it comes down to the AI agent now, it's more like the agent is gonna be prone to attacks that are focused on LLM, like natural language type of things. So like social engineering is a good example, right? Like LLMs are very much keen on like doing what the user says. That's how they're programmed. They're programmed to like, make the person happy and like keep using it. And so they'll often like if you intercept or like find some kind of way to like trick an agent, social engineering is one like really, really big one where I think that's going to be an attack surface for that. Other than that, I think the stuff that I talked about earlier as well, like code injection, right? Prompt injection, like finding ways where that we're not thinking. Like the Morse code one was really interesting, right? Like the Morse code attack. No one had thought that anyone would use a agent to do Morse code to like hack somebody. Like that's like completely like you can't even think that thing up until it happens.
It is creative, right? But like
super creative. And I think we're gonna see more stuff like that where it's like, oh, okay, well, we're not thinking about it, but like I don't know, like somebody hacked an agent with Swahili or some like weird language that you wouldn't think. So natural language is a weird thing, where it's so adaptable and manipulatable, and can be
by the way, how are you?
interpreted.
What best practices do you have to like try and minimize this risk? Like I'm getting so much phishing attempts these days, and I have few things that I'm trying to do to like minimize the risks. But if you have any tips on that aspect specifically,
yeah, I mean, I always ask people to email me now. If someone telegrams me, I just tell them, hey, email me, because I want to know exactly the domain name that they're coming through. But then there's always a chance that they've got their email hacked. So that's not. I had one the other day where the guy like did a Google Sheets or like a Google Docs, and like you had to put in a weird code, and then it was obviously like a scammer. So I just ignore that stuff completely. Like I don't even, if you want to communicate with me, just send me, raw text. I don't. We'll just do it that way, and otherwise, I don't want to be involved. Or I'll make people use my Calendly, and be very cautious again on the email address that's used to register to talk to me as well. Like no Gmails. I only let people chat with me that have official emails.
Awesome, that's helpful.
Mm-hmm.
Okay, next short question. Do you foresee a future where DeFi protocols explicitly require AI agents to post financial stake, cryptographic proofs, or insurance bond before they are allowed to interact with real liquidity pools?
Yeah, I think it's an interesting one. I think that staking for agents is probably the next natural step to, create, some kind of formality and verification of assets. So, for a while we had we were working on like a special spec for X-Row 2 at EdgeNode, where it was called the deferred payment scheme. And so just the idea is you have an escrow contract, and so the agent would have this kind of escrow. It could be a stake, or it could be just like a contract, that basically is like locking up some funds for a while, and then it can kind of do its thing or whatever and make sure it's not doing anything malicious. And then after a certain period of time, it can withdraw that, right? So yeah, 100%. Like staking cryptographic proofs, like ZK proofs that prove that the agent is owned by a certain human, or prove that they are operating in a trusted execution environment or whatever. Also the insurance stuff, yes, makes a lot of sense. Proof that they have like some kind of notarization or something that they're allowed to act on behalf of the user. That's all going to be very important and useful.
Awesome. And few last questions. So, are there any like mistakes for builders or developers that you're familiar with that you would like to help our community avoid when building applications, or basically anything?
Yeah, I would just say that don't give up. Don't forget, don't be afraid to ask for help, and try to find people that are experts and ask them. A lot of times people give up quickly, or fall into this kind of mode where they don't think they can do it. Just put your foot forward and try to find the right person to talk to, and you can get support.
Awesome. And I think in this AI world now, it's much easier to just like get the like first aid help, at least if not an expert from AI. It's usually at least can help direct you in the right direction most of the times. I'm not sure if you agree with that, but for me, it changed how I work with complex things.
Yeah.
Okay, last question I have, unless you have anything else you would like to share. I would love if you have a tip for community members, developers, entrepreneurs, any tips that you think can help them become better what they do today.
Yeah, I mean, I try to work in public, like build in public, show off what you're doing. Video is very, very powerful right now. So doing these kind of things, like finding people that you can, teach online or show off what you're working on, connect in different ways that you wouldn't normally feel comfortable with, I think is super valuable, and you'll get noticed. You're more likely to get noticed that way, right? Also, look at like if you're trying to get funded, BankerBot is kind of a cool tool that I think people are maybe not aware of. BankerBot is doing a lot of like funding mechanisms, and I'm really like excited to see how that pans out. But like, if you have a project, you can register your X account with the BankerBot, and people can help fund your project through fees and stuff like that. So that's another interesting thing that I would say is valuable. Yeah, BankerBot's really cool, and they're kind of trying to position themselves as a new funding mechanism, as an alternative to like venture capitalism. or maybe not an alternative, but like complementary method, right, for doing stuff like that. So look at BankerBot.
Some kind of crowdfunding tool?
Yeah. So basically you can create, like anyone can create a token for your project by your X account, and then you earn like a certain amount of fees and like native tokens for your project. So it's kind of like a really nice way to get funded through there.
That's awesome. I didn't know this one.
Yeah.
Okay, Kevin, thank you so much. This was a pleasure.
Thank you.
And yeah, I can't wait to for the next time. But thank you
Thank you
again
so
for joining
much.
us. And yeah, we'll continue. If any of you guys have any questions for Kevin later, you'll be in the Telegram chat. You're invited to ask questions there. And try to. I can't promise Kevin will be available, but I hope he'll do his best. And we'll send later all the different links we were talking about in today's conversation. You'll get the repos and everything on GitHub. And yeah, thank you again, Kevin. It was a pleasure. And yeah, really enjoyed our time.
Thank you so much. Have a great rest of your day. Okay.
Awesome. Thank you so much.